you, Fiona. Thank you, David. And I have to extend a huge thanks to those guys. So we were right. A few of you were here for Respond, which is just next door and Building 10 that we had on today. And actually, David and Fiona volunteered all day to chief cat herders. They were wrangling all the speakers. And I really can't thank them enough for that. So I've been thinking to myself, why on earth did I agree? After having got up this morning about 4 o'clock, having emceed all day at the conference to come and speak. But really it's because of them and the amazing things that they do and the amazing event and the community they built here, which is fantastic. So as I sit here with my feet aching, exhausted, I will keep thinking of that. Last year we had Ethan Marcus and myself speak, but the thing was it wasn't on the same day as the conference. That was the mistake that I made today. And it's also very exciting having brought Andy out here, Andrew out here to Australia, that he's going to speak, and that's a really rare opportunity, particularly younger folks in the room. You really, it's a chance you won't often get to see, so it's fantastic having him here. In the meantime, by the end of this, you'll probably be throwing things at me. So I'm going to talk about a thing called simplicity. And the entire basic tenor of this presentation is stolen entirely from a guy called Rich Hickey. So Rich Hickey is the inventor of closure and closure scripts, and it's a fantastic presentation called, basically about the difference between simplicity and easiness. He applies that more broadly to software engineering. It's something I apply to software engineering on the web. Because that's actually, those two things might sound incongruous, and to an extent they have been, because I think a lot of us on the web haven't really been doing it from the perspective of software engineering. I think there's a lot we can learn from software engineering about what we do on the web. And I'm going to talk about that for the next 20 minutes or so in a reasonably polemical way. I don't necessarily believe everything I'm saying. Well, maybe I do. Don't take it personally if I offend you. Think about it. All right. So there's a guy called Edgar Dijkstra. Has anyone heard of Dijkstra? Yeah. Right. Awesome. So he can send students in the house and they make you read this guy. This guy invented modern software engineering, right? And this is a fantastic quote of his. Simplicity is a great virtue, but it requires hard work to achieve and education to appreciate it. And to make matters worse, complexity sells better. And this has been true about software engineering and the products we've built for the last 40 or 50 years. So the irony in that, the seeming irony, is the idea that simplicity is hard work. And so how does that come about? How can simplicity be hard work? Right? So there are a lot of quotes you can read from, Einstein, all these famous people, Joni Mitchell, about simplicity. But this is one I like the most, which is, it is not a daily increase, but a daily decrease. Hack away at the inessentials. And this is genuinely a quote from Bruce Lee. I couldn't sing it. It sounds like Bruce Springsteen, right? Bruce Lee. And even that word hack in there is kind of cool, right? And I think there's something about that. It's to say that making things simple is really hard work. But I think we've lost sight of simplicity, right? And I think we shy away from hard work, right? So what we have known in the software engineering world, and just to put a little asterisk there, I am a software engineer. That's where I come from. I did software engineering at the University of Sydney in the 1980s, right? Yes, pity me, right? I did things in COBOL, right? Seriously. So, but there's a lot we learned. The thing about software engineering, we learned a lot about how to do this stuff right 50 years ago. And the web hasn't cottoned on yet, because we're kind of faking it still on the web. I really feel like. And there's a thing when you do new things, is you sort of think, it's like I have young kids and they all think they know everything all the time, right? Because they haven't learned what they don't know yet, right? And I think that's true on the web a lot of the time. So I think we should go back to software engineering on what we've learned. And one of those things is, we've known that complex systems become increasingly expensive over time. They take longer to build, and in fairness, they often never completed at all. In software engineering, we know that adding features is hard, and once you add them, you've got to maintain them. These are things we really know well. But on the web, we've had this sort of luxury where, even like Twitter, basically, a new version of Twitter comes out, we all talk about it, and they throw it away and start all over again, right? We don't build and maintain systems, we build them, throw them out, and start all over again. And in about 1968, in software engineering, they worked out you can't do that. Right? So if you can't work out the math, that's almost 50 years ago. And it was called the software crisis. And it was called the software crisis because software did things like fire missiles at other people, and there was a Cold War. So if your software didn't work, that was a real crisis. Right, so on the web, I think we've had this luxury where mostly what we build is fun and about communication, and it's not really serious grown-up stuff. And increasingly it is. So I think we've got to go back to these lessons that we learned. So at the base of it, web stuff is pretty simple. We've got HTML for content, we've got CSS for presentation, we've got JavaScript and the DOM for interaction and behavior. Right? So really, they're quite simple things. Each technology themselves has some complexity, but in the scheme of things, it's a pretty simple thing, right? But the truth is, using those technologies isn't always easy. And I think a big part of that is particularly around CSS, and this we're going to zoom in on the CSS part of things, is because CSS doesn't actually work like other web technologies, other programming technologies, right? It's kind of weird. It doesn't have like loops or variables or all these kind of grown-up things. It's kind of this really simple thing, it seems, but it's complicated. It's got like things like inheritance and the cascade and specificity. What's with that, right? And so the thing is, a lot of people come to these technologies and it looks different and weird. And their response is to try and make that difference and that weirdness go away. And then we have these other problems like the inconsistency of implementations, which is going away, but if you've been doing web stuff for a while, that was our biggest bugbear. It's like going back to Netscape 4 versus IE4, like the box model was different. These were the sources of our pain when it comes to using these technologies. So what do we do? So we're going back to kind of late 90s here, and this is what I call creeping complexity 1.0. So we started doing things like user agent sniffing, right? Because we knew Netscape 4 did this and IE4 did that. And so we started thinking, well, if only I knew what the browser was, right? Then I can have this code base. Only 2 code bases, right? And then we came up with all those CSS hacks, right? So we still use them, and a lot of people probably would glance at their code base now and think, what is that thing? And we had this doc type switching, and all of these added complexity. And they were there for very good reasons. They were there to help these fundamental problems. Well, they seemed like fundamental problems at the time because of the browser inconsistency. Right? But the thing is, now, nearly 15, 20 years later, they're still in our code base. We still code to them. We still worry about them, even though the inconsistencies in the DOM and the CSS implementations are long gone, right? So the point of that is complexity has a really long half-life. Right? It's radioactive like that. And I want you to keep that in mind because whatever choices you make now to make what you do more complex will last for a very long period of time. So the second iteration of complexity, I guess, happened around the Ajax revolution. We had there's a rise of jQuery and the monolithic JavaScript libraries. So what happened, pardon me, is we needed to learn these, not only JavaScript, right? We had to learn all these libraries themselves and their own quirks and their syntaxes and so on. And then, of course, they had versions, right? Because the versioning of jQuery, for example, is much quicker than the versioning of JavaScript. And then we started having to worry about the impact on performance, right? So we were suddenly layering all this complexity on top of what was supposed to be a simple problem, right? We had inconsistent DOM implementation, so we built this layer on top of that, but then we layer on top of that and that and that, right? So that was our second kind of iteration of complexity. But let's fast forward like 5, 7, 8 years. And now we have, look at the complexity now. We've got CSS frameworks, we've got CSS preprocessors, we've got languages that compile the JavaScript. Right? We've got MVC libraries, typical libraries, UI libraries, foundation libraries that kind of sit under all these. Then we've got boilerplates, and we've got build tools, and we've got minifiers, and then we've got these meta tool sets that kind of tie all this stuff together, right? So you've got Yeoman and boilerplate and mobile, and then they all rely on Ruby on Rails or Node.js. Right? You can see we're building this huge teetering tower of interconnected technologies that all rely on each other, each of which has been developed by different people in different places with all sorts of different agendas. So here's a little simple example. This is like, CSS is a pretty simple thing. It's got selectors, it's got properties, and it's got values, right? It's got a very, very simple conceptual model. But in order to tame this supposed complexity or the challenges we've got, in order to make CSS grow up, we've got, say, Sass, and I'm not only picking on Sass, but this is a particular example I found, where look, it just gets so immensely complicated. So then we have on the right one file, on the left all our Sass files, right? That's pretty complex stuff, right? We're building, the point is what we're building is very complex. Now, you might think this is, I'm some sort of purist, and I'm just hark the old days, right, where everything was simpler. But I don't think it is really that, because we talked a little bit before how complexity has costs and a half-life, right? Because this is where Hickey talks a lot, and it's really worth going and finding one of his presentations around this. So he juxtaposes simplicity and easiness, right? So simplicity is a function of what we build, and it's of versus complexity. So if I build something simple, it's not complex. If I build something complex, it's not simple. But remember, it's hard to do simple things, right? Because we have simplicity, which is about our personal, so we have easiness, rather, which is our personal experience as developers. So all the things we do, all that layers of language and helpers and frameworks and build tools, is not about what we're building, it's about our experience as developers. And you know what? Suck it up. Our job is to build things as simply as possible. And if it's hard work, well, that's our bloody job, right? And at the moment, I think we're optimizing for the wrong thing. We're optimizing for developer experience. And you know what? Too bad. We're optimizing entirely for that, and the problem is we're building these very complex things. And we've seen complexity's got a half-life, right? It's going to last for a long time. And as I mentioned, on the web, we've been able to throw things out, start again. We do campaigns, right? We do websites which have a relatively short shelf life. So why do we care about how maintainable it is, how debuggable it is, how learnable it is? It doesn't matter because it's going to be out of date next week and we'll build something new again. But that day is changing because more and more we are building mission-critical things. Banks are running on this, governments are running on this. These systems are sitting inside our cars. Everywhere we go now, the technologies that we're familiar with are powering the experiences and the underlying engines, right? So it's time for us all to grow up. So here's some of the things I think are really important about getting software engineering right, some key principles, and how, to be quite honest, the way we're doing things, I think we can do it more better. So Dijkstra again, he talks about one of the really important things about engineering is learnability. And it's a great quote. For me, the first challenge in computing science is to discover how to maintain order in a finite but very large discrete universe that is intricately intertwined. Right? And a no less important challenge is how to mold what you have achieved in solving the first problem into a teachable discipline. It does not suffice to hone your own intellects. You must teach others how to hone theirs. Teaching yourself is discovering what is teachable. So obviously, the simpler things are, the more teachable and learnable they are. And the more layers and complexity there are to getting to literally hello world, right, the less learnable something is. And I think we're at a crisis point around that. And there's a whole heap of things I'm going to talk about around that, but I think we have, for our own personal ease, once I know how to do things to make my life easier, I'm building things in a way that makes it really hard for others to come behind, come follow through, the junior developers, to know enough to be useful in the stack of technologies you use and the code base you're developing. See, this is these people sweated this stuff on an extraordinarily complex systems 50 years ago. So I think we owe it to them to look at what they learned and try and apply it to what we are doing now. Right, so most of the time learning to do a web stuff was pretty straightforward. You learn some HTML and you're actually functional. You can do some stuff with that, right? And then you can learn CSS and over time master it, so then you get more and more valuable. And then you learn some JavaScript and DOM and layer that on top. And a lot of the time we can view source and see what other people did, right? Try viewing source now, right? On Instagram. Right? Try and even work out what the hell is going on here, right? So let's look at the example, and this whole presentation started actually a lot with JavaScript and the way we approach JavaScript, and I'm zooming in on the CSS part. What about CSS preprocessors now, right? So you're a junior developer, what do you need to know? On top of all that other stuff, you need to know, or at least you should have a deep knowledge of CSS. But to be honest, I think a lot of the time, people don't. because they use a preprocessor instead to hide from their misunderstanding of CSS. They just don't learn it, right? But you also then need the deep knowledge of the preprocessor language and all its concepts, right? Because there are different concepts from simply selector, property value, right? It goes way deeper than that. And then, of course, it's all tied in the build environments, right? So there's all this complexity around just getting something up and running. So I'm old-fashioned, right? So I used to develop software where we had compilers, right? Something that happens in the browser, and you would have these complex. You would code, you would run, which would be compile, and then it would crash and we'd debug. And then these were horrendous cycles, right? Where you would go and make a cup of coffee while your compiler's compiling to go and run something to like crash 10 seconds later, right? So the web is such an amazing technology. We can just say Command R, and now, but of course, we don't want that. Every time we change any, it's got all these gems running in the background, or Ruby or Node. But the complexity we've introduced to what should be a very simple process, really. Okay? If you've never had to go through that classic code, build, run, crash, debug cycle, this stuff might seem that bad to you. But if you've been and lived through that, right, you would appreciate how liberating the web development environment really is. And you want to throw all that stuff out to make your life a little easier. I mean, the problem there is I'm starting to talk about easiness, not simplicity and complexity. All right? So what are some other things that are really important? Debugability, right? We should be coding in a way that makes what we build more debuggable. And so developers do simple things like make typographical errors, and we linters and things can pick that up, but they actually do complex things, so things that are complex bugs, and they're hard to pick up. And kind of CSS often is like that. Now, the problem with CSS preprocessors, we don't have a CSS file and its impact on the DOM. We have lots of SAS files or other preprocessor files that get turned into one or more CSS files that then have this impact on the DOM. And if we want to work backwards from the impact on the DOM to actually what's happened, we can't. Unless we introduce a whole nother technology called source maps, right? And of course, to use source maps, you've got a whole lot of build stuff involved with that. I mean, can you see the complexity we're bringing, or why? So I can type less keystrokes, so I can do auto prefixing, right? Because like with variables, I don't have to go and find and replace a few color values. I mean, seriously, what are you giving up for that? Right? You're building really much more complex things in a much more complex way to address an obvious and kind of frustrating pain point, but is it a genuine one? I mean, I don't think we're making good decisions around that. And this one to me is really important, and this is not Dijkstra, but this is a great quote, right? To obtain the deepest benefit from learning a new language, you must learn to think in a new language. It's like, when you learn a different human language, right? You don't just transliterate English into Japanese or Italian or Mandarin. That sounds ridiculous. And it's so with programming, right? You don't use a functional programming language in the way, you don't just try and translate all your procedural concepts into a functional programming language, right? To me, this is really important, right? You don't just translate your favorite programming language syntax and idioms. You actually learn what it is. And I think this is a very significant problem we're having right now with CSS, right? So, here's the great revolution of the web that is vastly overlooked, and I think shamefully so. The web is, for the most part, a declarative environment. So if you know anything about programming languages, there are two kinds of programming languages. There's a thing called imperative languages. They've got for loops and if then else, right? Declarative languages are not about how to do things. I don't have to tell the browser in intimate detail how to do things. I just want all my paragraphs read. Declarative. I don't care how you do that, right? And that's what CSS is about, and that's what HTML is about. And even aspects of the DOM programming with JavaScript are about. But with preprocessors, what we're trying to do is basically throw all that revolution out, right? With all these functional benefits, and basically replace it with variables and for loops and calculations and methods and all the stuff we're comfortable with because we're programmers, and programming does that, right? To me, it's like we learned a long time ago, that's not the best way to approach a new language. It is to really understand that language. And maybe, if you really and deeply and profoundly understand it, at that point, if you see shortcomings, maybe you can fill them in. But it strikes me right now what we're trying to do is, and I see time again, people don't really understand CSS, but you give them an imperative paradigm, the for loops and all that sort of stuff that comes with a preprocessor, then they take to that like a duck to water, because that's the sort of programming they've been exposed to. And so what the most important thing, is that cool? Is that cool? Does that matter? Well, it matters because what we're building that way is really complex stuff, right? We're taking something that should be very simple and build much more complex things with all the dependencies I just talked about. So the question I ask, and this is the key to software engineering. Software engineering is about one thing. It's about maintainability. Because your code base will and should last years and decades. It should be built with that in mind. But on the web, we've had this luxury. We can build this thing and it's not last for very long, right? As we move to a more product-focused world, as we do more and more sophisticated things with the web code base, we don't have this luxury anymore. So we've got to really take on board what we know about how to build maintainable things, right? So to my mind, when we're choosing all this stuff, we're optimizing for what I call optimizing time to first demo, right? How quickly can you demo something to your investors, to your colleagues, to your management? We use Bootstrap, chuck it in there. We use this framework, chuck it in there. Quick, we can quickly get to this. But the fact that that code base is going to live 1,000, 10,000 times longer than that time to first demo. And yet we're optimizing for that very first time. And what we're doing now is building these very complex systems that incorporate a whole bunch of stuff that we don't really understand very well, and we certainly don't necessarily need, that's going to have to live on indefinitely. I mean, anybody who's an Angular 1 developer has just learned that, because Angular 2 comes out, and there you go, pretty much, you've got to start all over. And we're going to see that time and again. And it happens with jQuery as well, happens every time. So we got to ask ourselves, are we really building for maintainability, or are we forever chasing yes, new, shiny, cool stuff? That's fun, right? It's kind of our monkey mind gets kind of distracted by learning something new and playing with that and doing new cool things, right? I think we have to learn from the errors of the past, the lessons of the past, and software engineering learned these things over a long period of time. So I think what we're doing right now is we're focusing on our own convenience, our own supposed productivity, which we measure in keystrokes, not in like the long-term viability of the product that we're building, the code base we're building, right? But by optimizing for that aspect of it, we are building things that are harder to debug, they're less readable and learnable, it's a lot harder to get. Your barrier to entry for someone who can work on your code base just jumps up massively. Why? Right? Why do they have to know all these extra technologies, right? And of course, you're making something much less maintainable. And then I'm not even mentioning all that build tool stuff that just reminds me of compiling in the old days that kind of I thought I got away from. I mean, literally, are we insane? So there's a great quote of this I dropped out, which is from George Sacchiana, who famous quote of, those who do not learn from history are condemned to repeat it. But he goes on to say in that same very famous quote that essentially, if we don't learn, we're in this perpetual infancy. And if you know infants, and I have 4 young children, they're always excited about the world, which is great, right? But it's because the world is always new to them, right? That's the nature of being an infant. And if we're always distracted by something new and shiny, and we're not really realizing the long-term implications of what we're doing and how we're doing it, we're just children. And I think in a way there's a kind of naivety to what I'm seeing, the way we're building many of the things that we do. So I think what we really need to do is to think about our ease and the implications for the complexity of what we're building. I'm nearly done already. And think about, suddenly if we do these sort of things, we have this lock into indefinitely in the future. Your whole code base is now hostage to non-standardized technologies, that even if they're widely adopted, that are owned by a very small number of people who may not care less in a couple of years, right? I mean, let's face it, jQuery is a legacy technology, right? JavaScript's not, the DOM's not, CSS is. Everything else will be legacy, right? We've diminished vastly the pool of people who can actually work on our code base. We've increased the complexity of debugging what we do, and just the whole overall development environment we've increased. And for what? As I mentioned, for our own personal convenience right now, sorry, let's suck it up. That's our job, to do hard stuff, right? So I'm not saying we should never do new stuff, right? I'm not saying we shouldn't move the web platform forward and the technologies and tools forward. But I feel right now there's this rush away from the core web technologies. There's the disparagement of the DOM. You know, look at React and the whole approach of saying, well, the DOM's broken, we're going to do it all over. Like, it's like Flipboard building a thing entirely in the canvas because 60 frames per second. I mean, like, which Moore's law tells us is an 18-month problem, right? At the moment, we're fixated on optimizing for very small edge cases a lot of the time, right? But this is a really big issue because the web has kind of been a toy for the last 20 years. I love the web. I've always lived for its promise, but its promise is starting to come. And we've got to grow up. And we've got to do things in ways that are hard work, but we've got to learn from people who've built really rich, complex, sophisticated systems in the past. Not just chase silver bullets, right? Fred Brooks, go read him, right? There are no silver bullets. And I think time and again we think, if only I use this preprocessor, if only I use this approach, if I only use this framework, it's going to solve all our problems. We just know that it doesn't work like that, right? So I think we just basically, what this says is we have to grow up in what we're doing. We're going to go back to the classics. We're going to go back to Dijkstra. We're going to go back to what they learned in software engineering. It doesn't mean that we shouldn't be doing new things, but we should really hold every new thing we do up to a very rigorous standard. We shouldn't just do it because, geez, I just saved hours today. We should do it because we just built an awesome thing for the next 5, 10 years. We have those foundations there. They're there. Let's not run away from them. They're really quite well designed. They're designed by really smart people, and they've got the wood behind the arrow of all the browser developers and the extraordinary resources. You've got some amazing people working on these technologies, both on the standard side and in the browser. So, you know, compared to like who's working on some of these other things, how long are they going to be? How long are you going to stake your product's life cycle on a framework that's been around for a few months, looks pretty awesome, and a couple of people are working on it? Because what we do is much more about coding. It's just not about, actually, it's very little about writing code, right? It's about what we're building, and I think we've lost sight of that to an extent. We need to be trying to address the complexity of what we build, and not worrying so much about the easiness or the hardness, the difficulty of that process, right? Basically, that's just saying grow up. That sounds like a bit of a downer. I tried to be polemical, I'm just got very quiet. It's polemical, I'm throwing a squib out there. But I think we've kind of slipped by. I think we've been able to like play with new cool stuff and it's all been fun. But it's getting serious now, right? We're building really serious stuff that people's lives and livelihoods and everything else depends on. And I think we have to grow up in how we go about that. And I think some of the things we've been doing, the experiments we've been doing, will become part of the core of the web technologies we work with. But others will just fade away because they're illusory. They're like a mirage. So that's me. Be polemical as you like. Disagree all you like. I'm happy to debate this. But I think it's time, as I said, for us to grow up with the technologies we use and start thinking about things you use every day. Which of those are you using just to like be a bit of a crutch? How are they really helping the product you're building be great over the next 5 to 10 years? Thank you very much, and have a beer.